Good evening, everyone. My name is Evangeline Pardasie, President of the UTT SPE Student Chapter, and it's my pleasure to welcome you all to this evening's technical talk. So we all know that decarbonization of the energy sector requires urgent action on a global scale. And while a global energy transition is underway, further action is needed to reduce carbon emissions and mitigate the effects of climate change. Renewable energy and energy efficiency measures can potentially achieve 90% of the required carbon reductions. With this in mind, the UTT SPE Student Chapter is pleased to host Pioneering a Path Towards Decarbonizing the Trinidad and Tobago Energy Sector, facilitated by NewGen Energy Limited. So to start off this discussion, we have Mr. Philip Julien, Managing Director at NewGen Energy Limited. So Philip Julien was born and raised in Trinidad and continued his tertiary education in Canada, graduating in 1993 from McGill University in Montreal, Canada, with a bachelor's in chemical engineering and a minor in environmental engineering. After working in the Canadian engineering consulting sector, he returned to Trinidad in 2001 and has been integrally involved in project development and consulting activities in the local energy sector since then. Philip assumed the role of Managing Director of KNSJ Systems Limited in 2019 and diligently led the development of NewGen Energy Limited as one of his flagship projects. He is also the founder and chairman of the Heroes Foundation, a registered not-for-profit non-governmental organization which was established in 2002 to create the next generation of heroes. So Mr. Julien, the floor is all yours.
So wonderful introduction, Evangeline, and thank you also for this great opportunity to connect with UTT and by extension all other participants on the call. Honestly, today is really about you and about the future of TNT. And what we in NewGen have been working on is something that we really want you to look at the lens of our next few slides from the perspective of how can you get involved to take things to the next step. So with that in mind, I will share my screen and go through a few slides that should hopefully do the trick. So is everybody, Evangeline, are you seeing my screen successfully?
Yes.
Okay, very good. So again, after that great introduction, what I'd like to do is quickly introduce some of the other NewGen pioneers of this initiative, some of whom you'll be hearing from today. Anthony Holder is our technical director. Zindzi John is our corporate affairs coordinator. And Mr. Mushtaq Mohammed, who will not be presented today, is another director of NewGen. Anthony will be focusing on what he does best, the technical side. Zindzi will be focusing on what she does best in terms of the social and corporate commitment of NewGen in this new low carbon era that we are entering. So that leaves me to talk a little bit about, I guess, the pioneering aspect of today's conversation. And I think the best way to get that started is really just to admit that, pioneering, I guess, runs in the family. So for those of you who don't know, Professor Julien is my father. Perhaps you guys may have connected the dots by now. And while I'd like to say it runs in the blood, what I can say is growing up in a household with dad and mom, pioneering, I guess, was just considered a daily day's activities. So the space that you see us moving in, whether it's genetic or environment, I owe a lot to my dad in helping us get that space, not only personally, but professionally, because as he retired from KNSJ Systems and offered me the opportunity to take its reins about 1.5 years ago, it really created the space for something like NewGen to be born out of the fundamental concepts that Kenneth J. Systems was founded on by my father about 20 odd years ago. And it's really in that space of ensuring a sustainable future for the energy sector of Trinidad and Tobago. I had the opportunity to build off that philosophy and expand into it with people who were as passionate, if not more, and in some cases much smarter than I am, to come up with something that really embraces the future and makes that undertaking of Kenneth J. Systems much more relevant. So without further ado, ladies and gentlemen, welcome to NewGen. So you will see that the word new generation shows up regularly in the whole spirit of what NewGen is in service of. It is very much in the space of charting that path for you to help the country decarbonize through the utilization of renewable energy in our existing energy sector. Our vision is really to be a pioneering influence in this all-important energy transition for our country. And we see the way of doing that is through the advent of this new hydrogen economy that I invite all of us to embrace and to be part of for the sustainability of our country's energy sector. So if I had to summarize what is NewGen's role, it is really to pioneer a declared future of hydrogen. Now that space of a declared future is not for the lighthearted, and it's normally best driven from the leaders of countries. You know, one of the most famous examples of a declared future was when President Kennedy declared that the United States would be going to the moon before the end of that decade. And in 1969, he was proved correct. But we're no strangers to declared futures, and that's the key message for all of us. Trinidad and Tobago has been declaring futures for decades. And again, decades ago, it started from the very top, from our first Prime Minister, Dr. Eric Williams, who essentially declared that we would be expanding our energy base instead of simply accepting the revenues from the royalties to create a meaningful energy industry for our country and for the people of our country. And he surrounded himself with people who believed in this declared future and took it on board. And a lot of what our country has to offer today was built on the backs of these energy pioneers who really created the backbone of a successful energy industry for Trinidad and Tobago. Yes, and you can see my dad hiding there in one of the photos. But what I want you to recognize, it took a team of dedicated and passionate individuals to make the current reality happen. And that is the call for the people on this call to take to heart as we are declaring this new future for the sustainability of our energy sector. Back then, the believers made the vision a reality, of which we're all in great thanks for, and all in service of ensuring that it retains and sustains a future for our country. Because what a wonderful outcome from their vision of and realizing that declared future in creating the largest industrial base in the Caribbean, right here in Trinidad and Tobago. And for this group, I don't need to go into the details as to what this means. I think the most important thing for everyone to be left with is we are a major energy exporter. We are a major player in ammonia, methanol, and LNG. And we are used and familiar with the management of whether it be industrial gases or energy-related products for the successful monetization, utilization, and export. So we are no slouches in this space as a country, and that makes it even more achievable for this declared future in hydrogen to be realized. The unfortunate reality exists, and this is a reality that we all have to accept, that we are in a current dilemma with our energy sector as it stands, not only in Trinidad and Tobago, but throughout the world. And this is the current reality that we all face and that you will face as you emerge from UTT and enter into your career path, as to something that we all have to take on seriously. We have taken a step of starting to fill this gap that has shown up so dramatically, which we will get to. And as this slide demonstrates, since 2010, and if we talk specifically to the petrochemical sector, we've been in that space of declining supply of natural gas to our ammonia and methanol plants. When you add to that the unfortunate reality of the current price structure of ammonia and methanol globally, you realize that Trinidad and Tobago is really in a challenged space, because the ammonia and methanol global commodity prices are not where they should be, and neither is the supply or the amount of natural gas that's available. And this has led to a lot of the shutterings and temporary, in most instances, closures of some of the ammonia and methanol plants. And this is an unfortunate reality that we have to face. But as I say, with every challenge, there's an opportunity. And what a number of people don't recognize is that of natural gas per se, we're actually short on the hydrogen that is derived from the natural gas. And that's a very, very important, I would say, revelation that we take for granted in the most part. You know, the creation of ammonia requires hydrogen, which is mixed with nitrogen from the air, and methanol as well requires hydrogen. And Anthony will go into some more details as to how this all works on a chemical basis. But what I want you to be left with is, currently, as of today, you know, Trinidad and Tobago has a voracious appetite of hydrogen. We're talking over 2 million tons of hydrogen annually can be consumed by the Point Lisa estate. And what the challenge is that the shortfall is in the order of 400,000 tons per year of hydrogen. You know, an ammonia and methanol plant, you know, as long as it's provided with hydrogen, it can do what it's designed to do. And that is the big opportunity, I would say, Trinidad and Tobago faces in the utilization of securing an alternate source of hydrogen, which happens to be carbon neutral and from renewable sources, again, as Anthony will get into. My role really is to show you, on that premise, where does the NewGen project fit in to the space of decarbonizing Trinidad and Tobago's energy sector. And I'll endeavor to do so in the next 2 or 3 slides. So bear with me. This is a current snapshot of where we are today. On the left, you will see, let's call this our natural gas supply, of which a component goes to the supply of our natural gas power plants, which provides us all with the electricity that we benefit from in our homes and in industry. The petrochemical industry, as I've mentioned, is now down to less than 100% of its original design supply, which correlates directly to the amount of revenue that the country receives from the sale of ammonia and methanol. So on the right here, just using some simple diagrammatic arrows, in 2020 compared to, say, 2010 or before, revenue is down, Carbon dioxide emissions are down, but I want to pause and say they're down, I would say, for the wrong reasons. They're down because of the lack of production of ammonia and methanol, which generates the carbon dioxide, but that's at the detriment of our economy and of individuals' jobs and professions, and overall well-being of life for the country. And as you can see, employment would be down. Excess heat, I'll come to that in a minute, remains, let's just say, the status quo. And overall, the petrochemical production levels are down. Let me talk a little bit about this excess heat, because this is another opportunity that the country has. So again, bear with me. You know, Trinidad and Tobago is awash with electricity. We have more electricity than we know what to do with. And as a result of that, there are a number of our power plants, again, Anthony will come to this, that only have what are known as simple cycle power plants, which means that it takes the natural gas, it burns the natural gas, it spins a turbine, and it creates electricity. But in that act of combusting the natural gas, there is a tremendous amount of waste heat that is given off by the power plant. I think we're in the space of 30 to 35% efficiency of the combustion of that natural gas. So there's a significant amount of waste heat that is simply emanated to the atmosphere. Then under normal circumstances, you would apply a combined cycle or a steam turbine that would capture that heat, convert it to steam, spin another turbine, and you'd get even more electricity. What you'll see is the NewGen project now allows for a business case to be made that if that additional electricity can be generated without burning a single extra molecule of natural gas, which is the case here, that now creates what's known as carbon neutral electricity, which is as valuable to NewGen as renewable electricity. Renewable meaning coming from a solar plant, such as the light source BP Shell one, which we'll talk to a little bit later. Because at the end of the day, if there's no additional carbon footprint created with the production of our hydrogen, that becomes a very valuable product known as low carbon hydrogen, which can then be converted to low carbon ammonia, which can then attract a premium on the international market because of its lower carbon footprint. And Anthony will take a deeper dive on that. So this is what NewGen is in service from. This is our declared future, which I think I've essentially talked through, where NewGen will acquire the combined cycle electricity generated from a new steam turbine, combine that with the green electricity from the solar facility proposed by Light Source BP, and take that carbon neutral and green electricity and convert it to hydrogen, the manner which Anthony will talk through the form of electrolysis of water. We take that carbon neutral and green hydrogen and we use it to supplement and complement the existing natural gas supply that is provided to our petrochemical industry. So not only are we adding an additional feedstock or an additional source of hydrogen to our, say, starving petrochemical industry, we're also adding that hydrogen in a manner that's considered carbon neutral. And by definition, that starts the journey of greening our petrochemical industry, which, as I mentioned, creates greened ammonia products, which will ultimately attract a higher commodity price when compared to the traditional gray ammonia that's currently made around the world. So this ticks all of the metrics in the right direction, noting that carbon dioxide emissions now are coming down for the right reasons, because we're creating hydrogen without having to combust fossil fuels. And this is the declared future that we are in service of, and we're going to do our best to start delivering on this in 2023, if everything goes according to plan. What I encourage everyone on this call to be in service of is building out from that initial step. and embracing this concept of a fully greened Trinidad and Tobago petrochemical industry, where we're able to create more and more carbon neutral and green electricity, to create more and more carbon neutral and green hydrogen, so that ultimately, ideally, we get our existing ammonia and methanol plants back up to their nameplate capacities, generating ideally more revenue than before, while ensuring and enabling a renewable supported energy sector of Trinidad and Tobago in a material way. So I'd like to conclude by coming back to answering the question, I mean, what really is NewGen's true role in all of this? And the reality is our role is to start so that you can help realize this new future for Trinidad and Tobago that we've talked about. This is a new low carbon future that would include green hydrogen, green ammonia, green methanol, biofuels, waste to energy. We can be a front runner in the global research and development in many of these emerged spaces. We can convert our fabrication and construction industry to be in support of a renewable-based future, and much more to come. You know, we may be blazing this one trail, but it's in service of you being the energy pioneers of tomorrow, because that is what it's going to take for us to sustain and expand the energy sector of Trinidad and Tobago that we currently have, with your support and pioneering contribution. So ladies and gentlemen, I'd like to end by saying the next energy revolution begins today. I thank you.
Thank you so much, Mr. Julien, for that insightful introduction on NewGen's role in decarbonizing the Trinidad and Tobago energy sector. So continuing on, I would like to introduce our featured speaker, Mr. Anthony Holder. So Anthony Holder, a chemical engineer by profession, has had a career spanning over 40 years in the oil and gas sector in Trinidad. Graduating from the University of the West Indies in 1979 with first-class honors, he began his career as a technologist at Trintoc, where he worked in positions of increasing responsibility over a period of 18 years and witnessed its transformation to Petrotrin from the merging of the acquired Texaco and Tesoro assets. Anthony next joined ammonia and urea producer PCS Nitrogen, where he spent 4 years functioning in senior positions, involving key roles such as technical advisor, operations senior superintendent, operations manager, and technical manager. Anthony's career led to 15 years at IPSL, starting in the position of operations manager at the ammonia division, then to plant manager, after which he had a very influential role in project engineer management at Woolley Parsons Trinidad Limited. As an effective leader with strong analytical and critical thinking and communication skills, Anthony brings nothing less than excellence to NewGen Energy Limited as their technical director. So I'll now hand you over to Mr. Holder.
Okay, thank you very much for that bio. Sounds so refreshing. I almost didn't know it was me. Yeah. Okay, so as Philip has indicated, you know, this part of the presentation will really address the technical side of what NewGen is involved in, and you know, I hope to achieve at the end of it some greater understanding on the part of the audience as to how you move from the idea to actually having product hydrogen and some other salient aspects of the project, because naturally there are other stakeholders involved in this venture, as you would imagine, given that we have to use electricity and water to produce the hydrogen. Next slide, please, sir. Yeah, so the topic I'm addressing today is the hydrogen and its seamless integration into the TNT petrochemical industry. That's all. Okay. So we've heard, I would imagine, you know, comments on the hydrogen economy. There's a lot out there in terms of news about developments in that regard. Looking specifically at Trinidad and Tobago, we can really achieve that intent through hydrogen production, which, unlike the existing steam methane reforming that predominates the entire energy sector in Point Lisas, go towards commercial electrolyzer technology, utilize an existing electricity generation capability from power plants that we have now, but which is not utilized because you require a combined cycle, so that this waste heat that Philip would have mentioned as exhausting from the gas turbines can be applied to steam generation, which is then used to drive conventional steam turbines to produce additional electricity. Of course, the feedstock for producing the hydrogen is water, and I believe that many of you would be familiar with the idea of electrolysis. In your early training, your early school, for those who have been involved in sciences, certainly. So the idea of using electrolysis to separate hydrogen and oxygen from water has been around for quite a while. The intention is, by virtue of applying green energy through a new project that is supposed to involve solar, we will then be able to combine electricity from the existing power plants, which will now be carbon neutral, because in producing that electricity will not involve any additional carbon footprint. The gas has already been burnt, and all that is happening is would have been vented, and we are just applying it now to produce additional electricity. And of course, all of the electricity produced from the solar power plant would be green. So thereby, we will have a combination of carbon neutral and green hydrogen as the output of the facility, since none of the feedstocks, the power to drive the process, the water, none of that involves creating any additional carbon footprint. Next slide, please. Okay, so how do we currently produce hydrogen? And the basic reactions involved in producing hydrogen, whether it be for a methanol plant or an ammonia plant, starts with natural gas. Looking there, you don't see natural gas in the equation, and that is because largely natural gas comprises of methane, and that is the molecule that is converted into hydrogen in steam methane reforming. As we can see here, the reactions involve the oxidation of the carbon atoms into carbon monoxide first. That itself releases a significant quantity of hydrogen, and this is followed by the carbon monoxide itself being further oxidized into carbon dioxide, and the water in the process again becomes converted into hydrogen. These reactions are referred to as shift reactions. The former is there's a primary and secondary reactions. So essentially, the goal of producing the hydrogen, as previously mentioned, is in fact to produce in the end ammonia and methanol. And by virtue of a reaction between nitrogen from the air and the hydrogen, we get ammonia. And in the case of methanol, it involves an addition, the addition of carbon monoxide or carbon dioxide into the feedstock. And that combination then allows the production of methanol, which is an alcohol, CH3OH. Next slide, please. Now, there are many concerns by the uninformed as to the hydrogen safety. And a lot of it is driven by perhaps familiarity with an incident that happened way back in 1937 when an air balloon caught fire and there were fatalities as a result. And it was thought that there was a hydrogen explosion. More recent information suggests that in fact it was the paint on the exterior of the fabric used in the air balloon that was ignited by static electricity. There was a storm, and that what was burning was not the hydrogen. So, you know, this idea of hydrogen is a dangerous, explosive chemical really is not factual. In addition to which, some people confuse the idea of the hydrogen bomb, you know, with chemical hydrogen. The reactions involved in the hydrogen bomb are nuclear reactions. And to get to what is considered to be hydrogen fusion reaction, you need first to have a fission reaction, a nuclear fission reaction, to generate the millions of degrees of temperature that is required to initiate hydrogen fusion. So what is the myth? Hydrogen is a dangerous gas, very explosive. We just spoke to that. In fact, hydrogen has been shipped for decades in large amounts in trucks and ships without critical incidents. That may not be so much in our area, but certainly in Europe and also in the US and other industrialized nations. It's a very small molecule, and leaking is a critical issue. Let's think about that. Hydrogen can be contained in steel pipes and can be handled at pressures up to 1,000 bar without leaks arising from diffusion specifically. Diffusion, think about diffusion as the hydrogen molecules being able to pass through the pore spaces of the metallic material crystals and escape. In fuel cell cars, which run on hydrogen, again, the question is concerned with the possible explosion in a collision because you have this hydrogen tank, gaseous hydrogen tank. You see here that there have been exhaustive tests which debunk this, in addition to which more recent technology actually applies carbon type materials, high strength materials, to further reduce these risks. Next slide, please. So if you want to get an understanding of some of the safety-related risks with hydrogen, I think a good place would be to compare it with other things that we are familiar with. And here there are a range of properties that are important in terms of fire and explosion hazards. And we can see here that hydrogen does not stand out to the degree that one would expect if it has to take the name of being very dangerous. As a matter of fact, hydrogen, yes, has a higher flammability limit, which means that higher concentrations in air are still flammable as opposed to LPG gases, methane, propane, and even gasoline vapor. Its lower flammability limit is a higher percentage than most of the others. It is more easily ignited in a mixture of air than the others, yes, but the flame temperature is, you know, within the ballpark of the others. It is very buoyant relative to air, and this in fact is an advantage in the sense that it dissipates more easily rather than accumulating to form a cloud which can subsequently be ignited and explode. Yes, indeed, it has a low ignition energy in that it is more easily ignitable, but that too is a blessing in disguise because easy ignition means sooner ignition and less time for accumulation of a vapor cloud, which then, you know, produces a stronger basis for a major explosion. The auto-ignition temperature required is over 1,000 degrees F. In other words, in the absence of anything else, just purely from heating, it can auto-ignite at this temperature. The higher that is, the better it is, in that it's, you know, less easily ignitable than methane, propane, and gasoline vapor. Next slide, please. Yes. So let's talk about how these properties may, influence hydrogen safety. As compared with what, we know in terms of fossil fuels, it is 14 times lighter than air, so it means it disperses quickly. Both gasoline and propane heavier than air, they cool to ground level. The flames emit a lower radiant energy, so it's less likely to spread to surrounding areas in the case of a fire. There's no toxicity and no environmental concerns about contamination. It's less combustible than gasoline. Think about that. It is less combustible. Gasoline is 2 to 3 times more flammable in air than hydrogen. And we handle gasoline, very frequently. Many of us fill up at the gas stations, and while we do that, we smell gasoline vapors. We never, think that, listen, this thing is actually more flammable than hydrogen would be. It has a relatively low energy density compared to other fuels, and in other words, burning hydrogen does not produce as much heat as those others. And the reason being, of course, is that it has no carbon. In combustion, carbon plays a big role in the amount of energy released. Okay, so the one thing we need to be aware of, it has a wide explosive range, and we saw that before. Mixtures ranging from 4 to 75% in air can still ignite. The flame is invisible when it burns, and you can't smell it or taste it. Again, that means if there's a leak and you don't have the appropriate detectors in place, it could there could be a greater time that it leaks over before it's detected. However, again, just recall that because of its very light density, unless it's in a confined space, it dissipates quite fairly easily, and the concentrations will drop accordingly, taking it out of the dangerous range. Next slide, please. Okay, so at the heart of hydrogen production, what we call carbon neutral or green hydrogen production. This is what is presented in this slide. Essentially, we're going to be taking power from the grid. We already talked of that power being either solar or a combination of solar and carbon neutral. Electrolysis generally runs on DC power, so there's the need to convert from AC to DC. And we all know that in electrolysis, there's an anode and a cathode, and some kind of electrolyte. Well, in this particular case, it depicts what is called a membrane type electrolyte. Water is the feedstock, of course, and the products are hydrogen and oxygen. In this case, we would have to apply some purification to the hydrogen, mainly drying and oxygen removal to a lower concentration. And the oxygen itself is a potential product which can be marketed. Next slide, please. Okay, so there are various electrolyzer technologies, and perhaps the one we may be most familiar with, if not in depiction, certainly knowledge of it, is the alkaline electrolysis cells, AEC. And in these ones, there are solutions, or there's a solution, an electrolyte, and then you have the electrodes. And by virtue of the electrochemical forces, you have migration of the ions to cathode and anode, and the subsequent release of hydrogen and oxygen from the electrolyzer. The PEM, and that is proton exchange membrane, works with a membrane in lieu of these solutions. Similarly, you have an anode and a cathode. You have a point of entry for the water. And again, the oxygen and hydrogen are released at the specific electrodes. Solid oxide electrolysis cells is another technology. And in these, again, you don't have a solution. Now, there are advantages or pros and cons of each technology. And the most mature, of course, is the alkaline electrolysis cells. I mean, that, of course, should not surprise us. We know about electrolysis in chemistry labs and so on. There's always some electrolytic liquid involved in that. There are lower costs associated because you don't have to have noble metals in the electrodes themselves. And again, because they can be large, the economies of scale associated there which drive the cost down. So there's also, operating pressure is low with using this type. That may not always be an advantage. And it has a kind of limits in terms of how quickly it can respond to changes, in loads and so on. And that can affect, operating parameters such as efficiency and the purity of the gas itself. This one, the PM, is based on a solid polymer electrolyte. And this really came into being somewhere around the 60s through GE. It has been used mostly in a smaller scale applications. The efficiency is generally higher. The operation is more flexible. And, work is underway to continue simplifying the designs and also increasing the performance of these. So today there are many commercial electrolyzers based on this technology. Because it includes, rare noble metals, it's more expensive, it's more complex, and of course that, means it requires more maintenance attention. The solid oxide ones are still in the early stages of development. And, of course, what's driving that, they'll be more efficient. And they also, the high temperatures, and degradation associated with some of the challenges that are involved in bringing this technology to market. Next slide, please. Yeah. So if we look at the whole idea of utilizing low carbon electricity, it doesn't end necessarily with the production of hydrogen. Apart from reducing the CO2 footprint by approaching this way of generating hydrogen through electrolysis, you can also go beyond. Now, again, the purpose of producing hydrogen is in fact to make something else, typically ammonia and methanol. In this slide, we show that we can produce ammonia, the same as green ammonia, if we were to combine the output of an electrolyzer and a nitrogen plant, nitrogen separation plant, which starts with air, produces nitrogen. So we now have the ingredients to make ammonia without any carbon footprint. And of course, this is a required material or chemical for agricultural purposes, and in the face of increasing global population, there's no scenario in which the demand for fertilizer is going to be reduced. Just to give an example, by approaching the manufacture of ammonia in this way, you could have over 40 million tons just in Europe alone as a reduction. And globally, it will amount to 360 million tons. So, of course, this is the future. And you as young people should be part of that journey. What we are involved in here is the early transitioning from where we are now as essentially a fossil fuel producer, leaving a significant carbon footprint, and beginning the journey into eventually being a green or ammonia producer, in which, you know, we are having a positive impact on the global environment. Next slide, please. Yeah. Okay, so this now, let's take a look at, from that global perspective, what can we on this end do to eventually realize our contribution in that regard? And this really speaks to the value chain of our project. Essentially, Tech will be the one to distribute the power. That power itself originates from the solar facility, which will be green, and potentially from our existing power plants, which have, you know, either unutilized secondary power, unutilized, or may have to put in the means of capturing that waste heat and converting it into power through combined cycle. So that power arriving at the NewGen facility will allow the production of hydrogen, which will initially be marketed. And we're talking about green hydrogen being distributed to plants in Point Lisas. The green, initially, we are going to start with the Yara plant, and then consider others as we grow our footprint, ultimately resulting in, you know, other projects coming online which utilize ammonia produced through this means. Sorry, hydrogen produced through this means to actually produce ammonia. Now, the oxygen side of the business is also going to be developed with the intention of marketing the oxygen product to those that may need it. We've already had conversations with some of the existing distributors of oxygen, and that will continue. Next slide, please. Okay, so let's get into a little bit more of the NewGen project. What exactly will that involve? So it is planned on the basis of providing 27,200 metric tons of hydrogen to the off-taker. This would be equivalent to about a quarter of the typical hydrogen requirements of you know, an ammonia plant in Point Lisas. They don't all have the same capacities, but particularly referencing them to the later vintage of plants, which can produce up to 1850 metric tons per day. The capital cost estimate is expected to range between 300 and 400 million US dollars, and the electricity consumption will be in the ballpark of 170 to 200 megawatts. Water consumption, I mean, that is the feedstock, will be about 240,000 gallons per day, which is, in terms of the overall water supply in the country, just 0.1%. But I think more importantly is that this quantity of water is about the same that would be required to produce hydrogen through steam methane reforming. So, you know, we're not going to be adding in terms of water demand. It means simply that water which would have gone into the process anyway to produce hydrogen by steam methane reforming will now be utilized to produce hydrogen by electricity. Next slide, please. Okay, so to give a little bit more on the depiction, beyond the depiction on the previous slide, the project description could be considered in some blocks here. And of course, we have the main process, which essentially is the electricity conversion unit, the electrolyzers themselves, and the product streams of hydrogen and oxygen being compressed and purified as required. These could be considered to be the inside battery limits, which means that there are supporting infrastructure required to allow this. As we said, the feedstock is water, and the water needs to be purified to a higher degree before it can be utilized in this way. And the treatment facilities associated with that would be part of the offsites. In addition, you need to have cooling water systems, plant air, so you can run instruments, nitrogen for blanketing and purging purposes, and so forth. So all of these would constitute part of the outside battery limits equipment. Of course, there has to be infrastructure, roads to provide access to the site, administration building for offices, control room, laboratory, all of the facilities we would expect with a petrochemical plant. The off-plat part is not within the NewGen scope, but remember we spoke about the electricity and getting carbon neutral electricity. So what that means is that one or more of the existing power plants will then put in a combined cycle and thereby be able to provide the carbon neutral electricity through TMT to us. Next slide, please. Okay, so we would have started our project as part of the development phase of the project. A preliminary feasibility study would have been conducted, and arising out of this, there is some indicative parameters that we could speak about. There's further work underway, and that work is under a consultant, IO consultant, with the objective of giving us a greater technical definition and allowing us to have an estimate of higher accuracy, which is necessary to move the project along in the development pipeline. But on the basis of this earlier study, these parameters have been presented. So we're talking about very, very high purities of both hydrogen and oxygen. Pressures up to 30 bar. As we saw earlier, some of the electrolyzers can give you product at a higher pressure. Others, are operated essentially, atmospheric conditions. And all that means is that, the compression facilities would have to be appropriate to what your actual output pressure is from the electrolyzer. So let's look at some of the utilities and the power requirements, product output, and so on associated with our project. So in terms of the consumption on a ton basis, we're talking about roughly 55 megawatt hours. The freshwater demand is about 14 metric tons. Similarly, all these figures in tons, consider them to be metric tons. Hydrogen, of course, that basically it's approximately 8 times the oxygen. The oxygen is about 8 times of the hydrogen production, and that's simply because of the chemical formula H2 and the molecular weights of oxygen and relative to hydrogen. So this shows for every ton of hydrogen produced, there's 7.9 roughly. And remember, we spoke about the outside battery limits equipment. So this just shows the power consumptions associated with those, and the min water consumption per ton of hydrogen is about 10. And wastewater production, because essentially in purifying the water to the specification required to run the electrolyzers, there is a reject stream of wastewater produced, and this is an estimate of what that would be. And offsite, so essentially we were talking about what is the power availability. So our project essentially matches what can be made available. Next slide. Okay, I'm gonna go a bit faster now. I realize that the time has crept up. Okay, so this here just talks about some of the components that will constitute the equipment for the plant. And we kind of spoke to it before, so essentially we could just gloss over this. Let's take the next slide, please. Yeah. Right, so again, you need some kind of purification system. So that's the demand plant. You have cooling, compressed air. This PSA here is a means of improving the quality of the hydrogen, and that essentially works on the basis of it absorbs the hydrogen and depressures it so that you catch the components you want to get rid of in the solid bed, and a purified stream is released. Okay, next slide, please. Okay, I didn't realize I was right there. Okay, so that's it, and thank you very much for your attention. I'll pass it back over to Mr. Alia.
Thank you so much, Mr. Holder, for that very insightful presentation on the technical aspects with regards to hydrogen and its seamless integration into the TNT petrochemical production complex. So moving on, and to conclude this discussion, we have Ms. Zindzi John, Corporate Affairs Coordinator at NewGen Energy Limited. So Zindzi John is an MSc graduate in Renewable Energy, Sustainability and Technology from the University of Reading, United Kingdom. She obtained a bachelor's in Geology major and Geography minor at the University of the West Indies, Muna, Jamaica. Throughout her career, Ms. John has worked in the capacity of a research officer, a regional technical officer, and a project development and implementation specialist with a special focus on energy and renewable energy and energy efficiency, both in local and regional environments. The majority of her spent career life has been in the public sector, where she became well known for her ability to develop policy instruments and engage with the relevant industry stakeholders towards ensuring there is an all-encompassing path towards implementation. She continues to follow her passion by working towards implementing national climate change mitigation and adaptation measures. I'll now invite Ms. John to the floor.
Thank you so much, Evangeline. Hi, so good afternoon, everyone, and I am Zindzi John. As introduced, I'm the Corporate Affairs Coordinator for NewGen Energy Limited. Next slide, please. Thank you. Right, so to begin, I would just like to tell you a bit about my story. So my journey began officially about 10 years ago, where the topic of renewable energy in an oil and gas economy was unheard of. But yet, as I pursued, I went after my dream of crafting my career life to resemble one that is focused on giving back to the environment, firstly by creating my world centered around balance, one where what I take from it must never exceed what I put back into it. The journey was an extremely difficult one, I must say, and it was faced with many challenges. One of those challenges was actually converting non-believers of this vision and this dream of a sustainable energy development pathway. And it's one that you have to encounter people who didn't understand or who didn't see that vision. And those people were my friends, some were even in my family. And there were times where I would question my decision to persevere. But at times when my doubts became a bit too onerous, I would devise an escape plan, and this would often include traveling to countries where the dream I had was actually the living reality of citizens in European countries, in the United Kingdom, and in other Caribbean countries. So next slide. This brings me to the overarching vision of sustainable development goals, as most of you all should be familiar with. Next slide. And the fact that, NewGen Energy speaks to the fact of addressing particular elements of the Sustainable Development Goals, such as the Zero Hunger Goal, Decent Work and Economic Growth Goal, Industry, Innovation and Infrastructure, Responsible Consumption and Production, and of course, Climate Action. Next slide. So meeting this theme at NewGen Energy has afforded me the opportunity to believe in my dreams and the actualization of shared visions for sustainable development. Working alongside like-minded professionals in an organization that is extremely motivating, and it speaks volume to the need to finesse your circle and the persons you keep close to you. So you must always try to surround yourself with like-minded people who will encourage you to voice your dreams and to assist you towards putting them into actionable items. Now, the United Nations Food and Agriculture Organization in its 2011 issue report stated that the use of fossil fuels by agriculture has made a significant contribution to feeding the world over the last few decades. Energy from fossil fuels has increased farm mechanization, boosted fertilizer production, and has improved food processing and transportation. Next slide, please. However, due to global trends towards the phasing out of the use of fossil fuels-based energy sources, we have to consider the fact that if an inexpensive supply of fossil fuel becomes unavailable in the future, what then are our options for increasing food production? The reality is that our options may be next to none. Today, as I take you through an outline of our corporate social responsibility strategy, I hope that you are able to identify with an area or even several areas of interest that would encourage you to want to be part of this journey and part of this vision, not just with NewGen, but with the entire development pathway for Trinidad and Tobago. Next slide, please. Our CSR strategic document formulates and documents ideas in which NewGen Energy Limited can incorporate social and environmental concerns with its strategies and forecast the ways that the company can play a more responsible role as part of the business community of Trinidad and Tobago, the Caribbean, and by extension, our global society. Our scope is four-pronged and addresses environmental sustainable initiatives, ethical business practices, economic responsibility, and direct philanthropic giving. Next slide. Our main CSR aim is to promote energy efficient practices, demonstrate practical energy conservation methods, and create awareness around the harmonious use of the sun, the wind, and water to feed persons within our community. So the next slide will show our proactive measures to achieve this aim. Preserving the environment will be done through conserving energy with behavioral change practices and technology where applicable, through the calculating our carbon footprints and calculating our water footprints. Through donations and aids, we aim specifically towards the advancement of the agriculture sector, generating energy education, and fostering community involvement through the hosting of a variety of events. Volunteering will always be a practice within our organization, whether it be in-house, organized, or whether it be through partnerships or programs run by other NGOs and other stakeholders. Supporting the community and local food production is one of our main aims that will drive our vision of greening that whole aspect of local food production and the agricultural sector. So we will want to invest in local food production initiatives through initiating business partnerships with new and existing agricultural farmers to utilize green ammonia, which will be sourced from NewGen and its associated process plants as fertilizer. Learning. At NewGen, there will be an active investment in research and development. Additionally, we'll be continuously improving our operational procedures to ensure that there is alignment with international best practices. So next slide. And this is one of our, one of our babies. It's something that is going to be rolled out within the next week. So our energy education and awareness drive. And as we move from the aspirational element of our vision, which Philip would have alluded to in terms of new energy for a new generation, and as we move towards the inspirational sphere of influence of the project, NewGen will be actively participating in energy conservation, energy efficiency, and water conservation awareness drives. In collaboration with the Heroes Foundation, we will be partaking in a series of knowledge awareness and sensitizing programs under the title Heroes of Energy Campaign Plan. This will be made up of a digital pledge campaign on energy conservation, energy efficiency, and water conservation, and a Heroes of Energy League Learning Series, which is a 7-week initiative. It will be hosted on Sundays, I believe, from the hours of 4 to 6, where it will be designed to connect our nation's youth with industry professionals who can share their insights and learnings directly with the youth audience. Topics that we will discuss in this forum will include regulating for the people, my experience in energy, understanding the sector and the future. We're looking at where we are, the natural gas value chain, and looking at where we're going, an alternative future, and the enabling influence of our state, taking chances as things change, and learnings on energy. But further information can be found on the Heroes Foundation social media pages or NewGen's website and our LinkedIn page. So in closing, today we took you on a journey along the start towards decarbonizing Trinidad and Tobago. We've shown you where we've come from, and we've presented a developmental outline of our flagship project, NewGen, that will allow Trinidad and Tobago to once again pioneer transformative advancements in the energy sector. So it's all up to you now to align your beliefs with what we envision and what we think about, what's best for Trinidad and Tobago. And we invite you to position yourself along this inevitable development pathway for our country. So I thank you.
Thank you so much, Ms. John, for sharing your story and also the overview of NewGen's corporate and social commitments. So we'll move straight into the Q&A, and I see we have several questions here. So we have one question from Dr. David Alexander. My question to Mr. Julien is, in slide 23 of his presentation, he indicated that we can be leaders in R&D in Trinidad and Tobago. How does NewGen plan to partner with the universities, UTT and UE, to accomplish this?
Okay, well, great question. And I guess today is the first step in strengthening that very same relationship with UTT. And of course, the same overtures will be made to UE. As the project develops, we intend to establish a very strong relationship with whoever the preferred technology provider is of the electrolyzer approach that we take. We see that as an example of really catalyzing a research and development opportunity between ourselves, the technology provider, and our tertiary education institutions as a good starting point. And naturally, we see that relationship progressing during the construction of the facility and not waiting on the end product to be realized. Yeah.
Okay, great. Sounds good. So we have another question here as well. How much net CO2 emissions will a project like this reduce TNT's overall emissions by?
Yeah, I can talk to that. So our estimate is it will be the equivalent of 250,000 tons per year of carbon dioxide equivalent that will be reduced.
Okay. And our last question here, because I'm seeing we're pressed for time, so we'll just take this last question. If it can be shared, what is the anticipated power consumption and what might be the split between solar and heat, assuming the heat acts as a base load to balance the intimacy of solar?
Okay. Anthony, you want to take that or do you want me to?
Let me make an attempt. So I think we, as we have it, the total demand falls in the range of, I said, 170 to 200 megawatt power demand. Out of that, I think we're only looking at about the fact, based on the capacity factor for solar generation, which is the estimate for the solar part of it is about 40. The combined cycle is going to give us about 100. Right? So largely we have catered for that in the electrical side of things, in that much of it is going to be carbon neutral. And based on the size of the solar project, and considering, you know, there's a capacity factor associated around that, we are going to satisfy the demand for our plant, which is in the range 170 to 200. Of course, you know, there's going to be more solar capacity in future projects, and that will be the vehicle through which we will move into other investments in the hydrogen pipeline. So I don't know, Philip, if you might want to add a piece to that or what.
No, I think you did it justice, Anthony.
Yeah.
Okay, great. So before we sign off, let me just share my screen. Yes. So I'd like to present the NewGen Energy Limited family with these certificates of appreciation. On behalf of the UTT SPE Student Chapter, we wish to thank you, Mr. Julien, Mr. Holder, and Ms. John for taking the time to facilitate this talk and really enlightening the UTT SPE community and industry personnel who are on this call on decarbonizing the Trinidad and Tobago energy sector and, of course, NewGen's role in this. So thank you, everyone, for joining in today. Take care.
Thank you very much. That's very much
Thanks again.
Yeah.
Thank you. You know, the opportunity is appreciated. Yeah.
Yeah, and we'll definitely keep in touch and keep our communication channels open.
Yes, definitely. All right, take care.
Bye-bye, everyone.
Okay,
Bye,
bye.
everyone.